A kickoff speaker is someone who sets the tone for the semester. He has clout, or she has clout, to command the stage, as it were. Tonight, we are honored to have such a speaker who does have all this and also is accomplished, humble, driven, goodness knows. He is fairly humble, and his least favorite thing is to talk about himself, so I'm going to share some things about Charlie Giancarlo. Charlie hails from the East Coast. He received his undergraduate degree from Brown, where he double majored in not only engineering, but the classics. He went on to study and get his master's from UC Berkeley in EECS as well, go Bears. And if that wasn't enough, he got his MBA from Harvard. He's still committed to those institutions, and he serves on the board of trustees at Brown, and he's a board advisor here for the College of Engineering as well. He started his working career at Siemens. I know there are a couple of people from Germany in the crowd, so you know where that is or who that is. And then found out after a couple years, he decided to start off on his own and found a company, which frankly in those days was not something very usual to do. In fact, if you had a class, there wouldn't be a class like this in those days. So it's kind of interesting that he did that. The company pioneered switching technology, critical for today's network devices. And after some ups and downs, he moved out west and worked in startups, helping to launch the first Ethernet switches. In 1993, he began a near 15-year run at Cisco, leading a leading networking hardware and telecom devices company. I am sure you all have had Cisco hardware and everything that you have done at home and also on business. He's held most positions there, including Chief Technology Officer and CDO. In fact, on his LinkedIn profile, it simply says he led all business units and all divisions at the company. At the end of his Cisco tenure, he went on to become the managing director for Silver Lake Partners, a private equity firm who invested over $45 billion. And I hope Charlie will talk a little bit about the difference between private equity investing and venture capital investing, or maybe you can ask a question about it. With all of his experience, his leadership capability, and frankly, his spirit, he is a very sought-after board director. And in fact, he's served on some of the boards of the most innovative companies in Silicon Valley, including Accenture, Skype, Arista Networks, Avaya, Blue Jeans Network, and near and dear to us, Netflix. And just when you thought he might be winding things down a bit, in August of 2017, he became chairman and CEO for Pure Storage, which is focused on innovating in areas like flash memory. The company has shown an extraordinary dedication to customer service, and the website claims Pure's ever-expanding list of customers are among the happiest in the world. And we too are extremely happy to welcome on this 10-year anniversary of his last Newton appearance, Charlie Giancarlo. One of the things that Charlie is going to be doing today is talking about some predictions. It'll be a first ever. I think as he finishes his lecture, he's going to go over some predictions that he made 10 years ago, and it will be the first time we've ever had somebody come back and kind of, for lack of a better word, grade themselves on the predictions, and hopefully make predictions for the next 10 years, so we'll see him in 2029 again. With that, please welcome to the stage, Charlie Giancarlo.
Thank you all, and thank you very much, Victoria. I really appreciate it. After all of that, I don't even know what to say anymore. So let me just talk a little bit about my time, both as a student, perhaps, and then what it's like early in one's working environment and working career. I think that might be most appropriate, and then perhaps some things that I learned along the way. So. Yeah, I grew up just outside New York City. In fact, right overlooking Manhattan. It was a great place to grow up. I had 3 brothers, and my parents came from a medical background. Honestly, as I grew up, I knew you could make money as a doctor or as a nurse or a policeman or a fireman, but I always wondered how did everybody else get along. So I grew up in a rather narrow world view in terms of just exposure to other walks of life, and I certainly didn't know what engineering was. I guess I was always a very science-oriented kid. I probably, like many of you, I was constantly taking things apart, and half of them I'd put back together again. Always working on fixing things. I think if I have one talent, it's that I can fix almost anything mechanical or electronic. I had been doing that since very early on. And I just, I loved all things about science. And I will say that I probably had one unusual characteristic when I was in high school, outside of blowing things up in chemistry lab. I somehow got it in my head that I wanted to start a company and run a company, even though I didn't really know what that was. And it kind of stayed with me over time. I did go to, obviously I went to college. I would say I was a good student, not the best student. Those of you in the back of the room, that's where I was. That's where we were known as skydeckers. We'd stay in the back of the room. But I was widely curious, so I took a lot of classes. As you could tell, the double major, but I was constantly curious and wanted to stay busy. And certainly I stayed busy. But even graduating from college, I really didn't feel like, I don't know how the departments will take this, but when I graduated college, I didn't really feel like I knew enough to get a real job and be employed as an engineer. I felt that my knowledge base was still pretty low. And that was why I decided to continue, well, that and the fact that the job market in 1979 when I graduated was terrible. So I decided to go to graduate school and came here to Berkeley, which was a great choice. I did consider another place across the bay, but decided that was just a master's factory and I wanted to get a real education. So. And I have to tell you, and I am not pandering to the audience. This was where I really got my education. I really felt that school came rather easy, and I just had to work like hell to really get through my course load here at Berkeley. It was a great place, and it was where theory became reality, and that was really important to me. Now, I did, as Victoria mentioned, I went to work for Siemens, and I worked for them in Germany, and that seem to be a bit of an aberration, but I had always wanted to go live and work in Europe for a period of time. Actually, my father had done that. He had gone to medical school in Italy, and I thought it would be fun, so I did it. And I didn't speak a word of German. Learned it, and of course, back at that time, the Germans didn't speak as much English as they do today. So it was to say it was a learning experience was really, is selling it quite short. I remember after about a month or two over there, I would talk to myself in English on the way home just so I'd have somebody to understand. It was, but after about a year or so, and you're very fortunate, I think, when you're younger, your mind can just absorb these things much faster. After about a year or so, I became fairly fluent. What was more interesting in that job, and now I'm going to give you sort of a bit of a story about what can set you off on a different walk of life or look at things a bit differently. Again, not necessarily pandering to the crowd, but so I studied semiconductors here when I was at Berkeley, and I won't embarrass you all and myself by telling you what the line widths were at that time. You basically could drive a truck through the line width of a transistor at that time. But when I went to Germany, I was about 22, and German engineers graduated about 26. And within a few months, what I found out was that I knew more about semiconductor engineering than most of the people that I was working with. And it was because of my education here at Berkeley. And at the time, it was really just Berkeley and Stanford that were teaching semiconductors. So if you were not a Berkeley or Stanford graduate, you had to learn it fresh, wherever it was that you were working from scratch. And what that meant was that, at a very young age, I had to take pretty strong responsibility, and I found out that a lot of the projects we were working on were just not being done well. For example, one of the chips I was working on was simply not going to work once it was made. It had several very fundamental flaws on it. And so I couldn't just work as an engineer. I had to start to argue with the management that they needed to take a different path, that we needed to change the design at a fundamental level, which also meant disrupting technology partners that they had. And it was kind of frightening, frankly, for a 22, 23-year-old kid who just graduated from school, didn't feel like they knew very much, to be arguing with people that were 10 years older or maybe even more than that, based on the fact that you felt that it wasn't going in the right direction. And that was really where I learned several things. One, it was that you really needed to stay true to the science and to the larger interest of having a company be successful than just going along with the flow or just doing your job or just doing what you're told. You really need to step up and try to follow the truth, wherever it goes and wherever it lies. And I'll tell you another thing, which I learned much later, but I guess I carried even at that point in time, which is you need to have the confidence in yourself and the trust where you say, well, what's the worst that can happen? The worst that can happen is you get fired. Fine, you go somewhere else, right? You have to have enough trust in yourself that you're not fearful of going down that more difficult path. That you're doing what's right for the company and frankly for the wider set of stakeholders by really trying to drive down towards the truth and what's right. And again, you have to be humble. Of course, you could be wrong and take in input, but when you're confident in your point of view, then you need to follow it and push it wherever it may go. The second thing I learned is I didn't want to be subject to the idiots above me. And therefore, maybe I needed to take on a larger role than just being an individual engineer. And that's what sort of prompted me in management, because what I cared about was creating a successful product. At the end of the day, what really drove, I think what's driven me for most of my working life has been wanting to build and deliver successful products in the market. And it wasn't enough just to work on something that was cool and neat and maybe even innovative. But if it wasn't successful in the market, then of what value what was the value of your work and what was the value that you delivered to the world? For me, I needed that last bit, which is that acceptance, if you will, of the product by customers, right? Because that's how you know at the end of the day that you're successful. So I did start. I actually started my first company. So after that 2 years at Siemens, I did go to Harvard Business School because I figured out I really knew very little about business. Now, by the way, I don't know that I would recommend that for everyone today. I think the world is very different now, and the amount of business education that you get just working, especially in this environment, in Silicon Valley environment, the amount of exposure you get to good business practices, to entrepreneurship. I mean, there are courses in entrepreneurship now in engineering, which there never were before. The amount of exposure you get to that is very high. Back in my day, I was a pure engineer. There was no gray. There was black and there was white. And you either got the right answer or the wrong answer. There was nothing in between. So for me, it was a very important step. but I graduated arrogant enough to start a company right after graduation, which was not smart. To add insult to injury, I started it on the East Coast in New Jersey, where I grew up. I learned many lessons, many of which they teach you in your first class of entrepreneurship. That is, associate with really strong and good people, get good venture backing, make sure that you are in an environment where you can attract strong employees. I was in an environment where no one would leave a reasonably strong pension at at New Jersey Bell Telephone in order to go to a startup, right? Trying to attract people who are willing to take a risk, those two phrases just didn't go together at the time. Despite that, we made pretty good progress. We were building early switching equipment for connecting at the time were IBM computers to their storage targets, and we were making pretty good progress. And really, what killed us, we had good venture backing. What killed us was the stock market crash of 1987. And most of you were probably pretty young when 2008 came along. But 1987 made 2008 look like a cakewalk. 1987, the stock market lost a third of its value in 3 days. A third of its value. It dropped from 1,500 to 1,000, literally in 3 days, and our venture capital just dried right up. So one of my backers, still believed in the concept and decided to bring us out to, or asked me to restart the business out in California. And that's what brought me and my family out here to California. And as Victoria mentioned, that startup, we built the first, so this is going to be embarrassing to everyone. So back in that period of time, and it's not that long ago, in 1989, the internet was still a private network. It was controlled by the government and tied together universities and different government agencies in what was known as DARPANet, right? It was open. It was so-called commercialized in 1991, and in 1992 we introduced and the internet was our smallest customer, and we didn't even know it as the internet. There were two companies that ran it, PSINet and UUNet, and their backbone speed. So the speed of the internet, coast to coast, the backbone speed was 1.5 megabits. No, you have not been subjected to 1.5 megabits in your entire life, I don't think. And this was the entire internet backbone was 1.5 megabits. Now, of course, there were several of those across the country, but still it didn't add up to very much. And we introduced a product that brought it up to 150 megabits, about the speed right now of your wireless router in your dorm room. That was the backbone. That was the innovation that we brought was that backbone. But it was during that work, when we were doing that, where the real prize and the real insight came to us. And so let me just talk about that a little bit. What got me into communications was I started out in semiconductors, but then when I was at Siemens, we were building semiconductors for communications. And that was really what was exciting to me. Digital communications was new. Prior to then, it was all analog and modem-based, right? If you wanted to put digital over the network, you dialed up and put a modem on it, and that's how you got it. And for the first time, digital communications was coming out, and that's what I had built semiconductors for. And it just, I started reading about Shannon and others about the potential for doing, much higher speed digital networking, and I thought that was really cool and really fun, and really being able to tie together computers at high speed. And I'll tell you a little anecdote. I had already been married at this point, and I went to my brother's wedding, and I think I was already out here in California. I went to my brother's wedding, And his new brother-in-law was working at Princeton doing research. He was a head researcher for nuclear fusion at Princeton University. Okay, so he was the one that was working on both the tokamak and the laser ignition facility to ignite, a bead of tritium and deuterium to create, nuclear fusion to power cities and countries and so forth, right? And so I was very curious about that. So we talked, a lot of the night about what he was doing and what his hopes were for building fusion to have, free and clean energy for everyone. And that it was going to be possible in the next 20 years. And then he asked me what I did. And I said, well, I'm building these, digital networks. And he goes, okay, what's that for? I said, well, it's for letting computers talk to each other. And he told me years later that he went home that night and he said to himself, geez, I don't know why computers have to communicate with each other. I feel sorry for this poor guy. So you don't really know where your curiosity is going to land you. You really don't, right? I mean, back then, and that was probably around 1990, 1991, the idea of having computers, my family didn't understand what I did for a living. So, and it wasn't until about 1996 when this word internet became popularized, where people actually thought then that they knew what I was doing. Because they knew there was this thing called the internet. In any case, go back to 1993, it occurred to us that the computers now were more and more being connected with Ethernet, but it was still a shared medium, meaning that lots of computers would share a 10 megabit connection. And since we can switch data at relatively high speed, why don't we just switch Ethernet? And holy cow, I have to tell you that literally in 1993, I could draw a graph. So not a single Ethernet port had ever been sold, or an Ethernet switch port had ever been sold. And I could draw a graph to the end of that decade and say that without a doubt, Ethernet switching is going to be a $10 billion market. I mean, that's pretty amazing, right? And it was just the insight that you were able to achieve by being in the business and understanding the fundamental technology and then where companies and technology was going. That then it could give you the ability to actually predict where this was going. And I did this prediction. And I did it to our CEO. This was the company I started, but it was funded by VCs and by a sort of a sponsoring company. And the CEO of that sponsoring company, I drew this out for him. And he said, yeah, that's not going to happen. And that's when I left and started with another company called Kalpana, where we developed the first Ethernet switch. By the way, that guy, Dan Warmanhoven, became the CEO of Network Appliance, which became another great company. But he really blew it by not being able to understand funding Ethernet switching. Anyway, so that was how I eventually ended up at Cisco. And along the lines of just wanting to really develop great products, I went to Cisco. It was, I thought, a big company at the time. It had 2,000 employees. It was was just about to cross over $1 billion in revenue. And I liked small companies. I liked, I thought of myself as an entrepreneur and starting companies. And so I thought, well, I think, I'll probably go off and start something else. But there were two things that was holding me back. One was, I'd been working then as a entrepreneur for probably about 6 or 7 years. And frankly, I was a little burnt out. So I thought, well, maybe I'd stay here for a while and just catch my breath. And the other thing was Cisco stock price was doubling every year. So I thought maybe I should vest a little bit because I still had a lot to vest in the company. But what I found valuable at Cisco was that they had a great culture there, but they had a great sales force. Their sales force could really sell the products that we had developed. At that point, it was both routing and switching to enterprise customers. And what did I like doing? I liked building products. Frankly, I didn't. Building sales forces were ancillary to building great products, but you need them. Otherwise, they're not great products if you don't have a good sales force. And so it gave me the freedom then to start working on other technologies while we were there. And some of them you may be familiar with. We developed the first Wi-Fi systems were developed at Cisco. But let me tell you about the first Wi-Fi systems, because I think it's also instructive. We bought a small company that was doing research in Wi-Fi, came with about 50 employees. By the way, it tripled the number of PhDs we had at Cisco. This small company had more PhDs than we had in the entire company, because as many, and those of you who's taking E&M? No E&M? Oh, okay. Well, anyone taking E&M, right? I mean, it's hard stuff. And so that's electricity and magnetism. Really understanding radio is really, really complex. So we bought this company and worked on Wi-Fi for about 18 months to get it to market. And you would think, right, that Wi-Fi would just take over the world, and be a huge market overnight. For 2 years, we couldn't sell Wi-Fi. This is the only Wi-Fi that exists, by the way, right? So we couldn't sell Wi-Fi for a wide variety of reasons. The security protocols weren't standardized. Microsoft didn't support it, so you had to have, a dongle and software directly from us. Large companies couldn't use it because, right at that point, they were using a shared secret. And if an employee leaves, well, they have it's like having one key to the office, that everybody has the same key to get into the office, right? So if someone leaves and goes to another company, all of a sudden that other company has the key and you're no longer secure. So there were a lot, also if you put it on the ceiling, you've got to pass fire code in 50 states, not to mention 212 countries, and all the fire codes are different. So there's just all sorts of issues. So it took 2 years, and my CEO didn't support it. He thought it was a stupid idea. You should stop the project. We don't have the money to continue funding this, and so forth. But then, of course, Microsoft introduced Windows, started supporting Wi-Fi, and that's when Wi-Fi started to take off. But I guess there's a couple of lessons in that. One is that too early can be as bad as too late, unless you're able to stick through it. And actually, I had learned about the possibility of Wi-Fi back in 1992. If we had started it then, several companies had started, but had gone out of business. And you probably wouldn't guess why right from the start. But in 1992, there was a critical thing missing for Wi-Fi to be successful. Laptops. There were no laptops. All there were desktops and something called luggables, which was a desktop with a handle on it. And so without laptops, you don't need Wi-Fi. And so no one bought it. It was when laptops became readily in wide use that we had that Wi-Fi became successful. Voice over IP was another innovation that we made. Very similar story. When we first put it out, it didn't have all the same capabilities as a regular telephone system. So it was very hard to sell. Customers that first bought it went through a lot of difficulty and trouble. Wasn't as reliable, but eventually, again, with a lot of work and effort, and often, and this is maybe another story, turns out that every business, every new product you introduce, even if you're in the same business, so, routing is communication, switching is communications, Wi-Fi is communications, voice over IP is communications, they're all completely different. The way you sell it is different. The knowledge that your sales force has to have is different. The channels, that is the resellers that are in the market that you might work with, who work with customers, are all different. The economic model, in many cases, is different. And as you go through a company, probably 80% of your work is not inventing the product. 80% of your work is figuring out how to get it to a customer in a form and with a set of capabilities that will get the customer to actually buy it, right? It's a lot of training. It's a lot of support. It's a lot of figuring out small modifications to make to the product to make it more interesting to customers. And you just learn this lesson, unfortunately, over and over again. And every time we, even today, introduce a new product, even though it's in the same business, we have to relearn these lessons all over again. So, you know, I think Edison famously said that that invention is 1% innovation and 99% perspiration. I think that's still largely true. It's a lot of detail that goes into making any successful product. So with that, why don't I, well, let me just say a few words about Pure Storage and what we do. So Pure Storage, we will celebrate our 10th birthday actually in October. So it's a 10-year-old company. I only joined 2 years ago, so I can't claim any credit for the success that the company had early on. It was the first company to use flash memory. So flash is what you have in your cell phones and nearly in all the laptops today. But prior to Pure, all computers used hard disk. And in fact, if you bought an iPod 10 years ago, you probably bought one with a hard disk in it. Hard disk, for those of you that don't know, is a piece of mechanical equipment. It's a spinning disk of rust, iron oxide. We were all walking around 10 years ago thinking we were, you know, just so cool, and we still had mechanical stuff in our computer. You know, our computers were still based on mechanical storage. You know, now it's all semiconductor. Flash is semiconductor. By the way, Berkeley was big behind flash. A lot of the early, one of my lab mates here in Corey Hall, Sanjay Mehrotra, was one of the primary innovators around flash storage. So Berkeley has a lot to be proud about here. These days, all storage is going to go to flash. It's going to go to semiconductor. That probably doesn't surprise you at all. It's more expensive right now than magnetic memory, but it's declining much more rapidly. And it's really allowing, I think, a revolution in terms of what we're going to be able to do with all the data. For example, our products are the #1 products that are used in artificial intelligence and machine learning environments, simply because of the throughput that we can enable with the data to feed GPUs and CPUs and so forth. The other thing that's amazing about it is it's much more sustainable. We fit a petabyte. Do you all know what a petabyte is? Yeah, so you probably have about 1/4 of a terabyte in your laptop. So a petabyte is 4,000 times as much storage memory. And we can fit that in the size of a microwave oven. In terms of magnetic storage, that would take a row of equipment from here to the end of the room. So we are much denser. And obviously use a lot less power as well. And there's a lot less waste at the end of the day. And it's far more reliable. So that's generally what we do. And that we're going to continue to innovate in this area in ways that I'd be glad to take on after. With that, I thought, you know, Victoria teased us and me with threatening to put up a slide that shows the predictions I made 10 years ago. So she said, I'm going to grade myself. No, you're going to grade me. See what you think. All right. So I thought 10 years ago that video was going to become much more common and that people would actually be broadcasting video from home. So that's okay, right? Talked about software as a service becoming much more of a thing. That is, applications being provided not as software inside the enterprise, but rather served out of data centers by the SaaS manufacturers. That's pretty good. I saw, oh yeah, I mentioned that confidentiality is going to be a real, that was part of what they'd be able to do was anonymize the data so that people could make use of the crowdsourced information without knowing specifically what individuals or individual companies put up. Is that it? It's like the Oscars, we're done? Okay. Virtualization, the rise of virtualization. Today, everything's virtualized and now containerized, et cetera. So, and then we talked about enterprise unified collaboration tools, by which we mean things like, just telepresence, or just utilizing a lot of video, as like Zoom, if you're familiar with Zoom, or BlueJeans, WebEx, all those things. So those are pretty good. Now, I cheated. How did I cheat? It was, I think it was Peter Drucker that basically said, the best way to predict the future is to create it, right? And I was working on all these things 10 years ago. Now, I didn't know I'd be, now, I didn't deliver these things, other people did, but I knew about them at their infancy, right? And these were the ones that I thought had the greatest chance of being successful. And so all of you have some insight into things that you're interested in and engaged in, and the thing you spend your free time on. You have those insights of your own. And the thing that you don't have, like I didn't have when I was in my early 20s, was really understanding better how the world worked, right? What were the kinds of things that the world accepts? What were the things you needed to have in place for them to accept the new innovations that you might bring out? Though that's what you need to develop over the next 10 years, is really getting a better understanding of the way the world operates, so that when you do have an insight, you know what the right time is, and you know that the world is ready for it at that time, and what the ingredients are that you need to be able to deliver along with that innovation in order to make it successful. So they also asked that if I might predict a little bit about the world going forward. Well, I think that, in a sense, it is going to be much more of a software world. A lot of things are going to go to the cloud, but I think you all believe that already, so that's not much of a prediction. But many more capabilities and so forth are going to head into the cloud. I do think that more of the physical world is going to become more software. What I mean by that is, if you're a biologist, I think it's going to be very hard for you to be able to continue as a biologist without data informatics, and to be able to really analyze what it is that you're studying from the big data standpoint. And in fact, even things like CRISPR and creating new, creating changes in the DNA of whether it's humans or plants or animals to eradicate disease or for other purposes, you're going to need to really understand how computers operate in order to be able to construct the engines that will both analyze and be able to drive the way that you might want to create new forms of DNA or fix existing forms of DNA. So understanding computers, understanding big data is going to be really a critical capability as you go forward in almost any walk of life. So again, I don't know that is a terribly profound forecast, but it is something that I really believe. Of course, I've got much geekier predictions for the data space. Right now, data is still very much tied to a specific workload environment. It's not free in the same way that applications are to be moved anywhere at all, or for applications to say, for any of you that have asked your IT department for more storage, you know that it just doesn't come easily. And I think that's about to change, where basically an application will call for the capabilities that it requires from a storage and data standpoint, and it'll be provided by AI and orchestration. So those are my forecasts for today. Well, maybe if I'm back in 10 years, I won't be working then though. I'll be in retirement gear, I think. So with that, why don't we open it up for Q&A?
So we have a good 20 minutes for Q&A, so I don't know if anybody's willing to start off our Q&A. Yeah. I'm going to pressure everyone in the room to get involved in questions. So be prepared.
Is this on? Okay, cool. Hi. So I was just reading recently about...
Can I ask you a question?
Oh, yeah.
Could you just say a little bit about what you're studying?
Oh, yeah, sure. So my name is Marley, and right now I'm studying nuclear engineering, and I'm hoping to do some work in a IOER, either a minor or by switching my major.
Okay.
And then I was reading recently about the medical industry's kind of migration into using some of the larger software companies, Google, Amazon, using their data centers to store medical data.
Yep.
So I wanted to ask about your perspective on how storing medical data in these larger centers will affect medical outcomes and what you think about that.
Right. Well, I think there are a couple of interesting elements about that. One is the whole issue of privacy, and I think that I'm personally very concerned about privacy, and personally I feel that our Fourth Amendment rights have been violated for the last 15 years and continue to be violated. That is, Fourth Amendment says that the government it shouldn't be able to have access to your personal information without a warrant. But frankly, there's been no case law that's ever been adjudicated about information that you might have on the internet. Even if you encrypt it on the internet, there's no case law that says that they need a warrant to go after it, which I think is criminal. They need a warrant to go. If you had it on your hard disk or on your laptop in your home, they need a warrant to go get it. But if you store it on Dropbox, they don't. And I think this is something that, or at least they don't feel like they do. It hasn't gone to the Supreme Court. So I do worry generally about our information being in the cloud because of the lack of the U.S. government's willingness to actually protect it, or any government for that matter. That being said, I think the whole idea of having anonymized medical information, assembled together and analyzed can only be good for our lifespans, right? And for helping cure disease, helping to, and not just disease, but just to help underprivileged populations that are living in parts of the country, where the water is bad or there are other environmental contaminants that we may or may not even know of, to enjoy a better life. And we'll only know this by having healthcare data be analyzed in a big data format. So on the one hand, I'm very supportive of it. On the other hand, I do worry about privacy.
Hi, my name is Ishal.
Hey, Ishal.
I'm a first year and I'm studying computer science intended. So my question for you is, what are your thoughts on 5G? And I think you mentioned a lot about, is something too early or too late? And right now there's not a lot of infrastructure to support that 5G network.
Right.
So what is your thought process on, what is the next step for, data transfer, whether it's from our phones or just in general?
Right. Well, 5G, for those of you that don't know, is just another step up in the speed of communications that we will have on our cell phones, right? So today you can get, somewhere around 10 to 50 megabits with a really good LTE or so-called 4G network. And with 5G, hundreds of megabits. We should be able to get hundreds of megabits. And there's even some question as to whether we'll need wired connections in our home with 5G. Personally, I think we will, because the airwaves are expensive and they'll get busy. But that being said, it's going to allow many more devices and a lot higher speed. Now, I'm personally having trouble understanding what I would do with higher speed on my cell phone. It's already dangerous enough driving 2 hours here and getting texts on my phone as I come. And I think all of us already do videos and other things on the phone. But it will allow for many more devices to be in the field. So IoT-like devices, Internet of Things, sensors on the ground for farming, the ability to have temperature sensors almost anywhere. Maybe it's going to be more data from your phone. I don't know how you feel about your phone giving out more data about itself and its surroundings. That kind of scares me a little bit. But it does mean that we're going to make more things possible. And the sense of the community is that it means that a lot more data is going to be shared. And right now, the wireless networks are not really designed to handle a lot more data. And especially from a this is somewhat self-serving, but largely from a storage standpoint. The networks don't store data. But if we have a lot more data that's going across those networks, it's going to need to be stored and processed somewhere. And the biggest load on the networks by far is video, right? Video is just a huge amount of information, and it's stored as a large amount of information. It's something like 80%. So when I got my start, 80% of the internet was porn. Today, 80% of the internet is video, mostly not porn. Yeah, it's cat videos. I think that it's going to want to be stored. So I think the other thing about 5G is it's an incredible amount of technology. As I mentioned, some of the most complex technology in the world is understanding radio, right? And all wireless is radio, that's what we mean. And it's a very complex technology. To give you a sense, the way it gets so much speed and bandwidth is if you hold up a 5G phone, there are probably something like 5 or 6 different antennas in different locations that are all sending you information, and they're sending you bits and pieces of the same information, and that's how you get so much speed. And coordinating all of that so it gets to your phone at exactly the right time in exactly the right order is really complicated. And that's what 5G is about. So it's very expensive. It's going to take time. Personally, I don't know that we're missing anything by not having it, but it's going to be very big for the carriers. So, we will definitely see it. There's a lot of controversy right now that we're not first, that China might be first in 5G. Somehow that doesn't really bother me too much. I'd rather be right than first in this case.
Come on over on this side of the room. All right, I got one up here. Charlie, while I'm getting there, a question for you, for all the students. We're all looking at, we're not all of us, but looking for different jobs and thinking about that. And you've been on boards for different companies. You've invested in different companies. I'm just wondering what you look for when you decide to spend your time or money with a company.
Right. It's a great question. And actually, you had also asked about private equity and venture capital, what the difference is. So I do invest in companies. And when I invest, I look for several things. One is just a management team that really knows what they're doing. Not just a great idea. I have to tell you, most great ideas are not single. There's not just one team that's pushing a great idea. Usually there's several dozen teams that all have something pretty much like the same idea. And so you're looking for a management team that is very capable, very experienced, sort of has been to the movie before, has maybe not started a company before, but has built something similar before, can attract good people. So you're looking for that. I'm just one of maybe a set of investors, so I'm looking for other good investors. There are probably only a dozen venture capitalists that consistently make money in the world, venture capital groups that consistently make money. And you might think it's because they're smarter, and there might be a little bit of that, but it's also because they're known as the best venture capitalists, so the best companies go to the best venture capitalists, and they get to see more companies than anybody else, and so they get to select the best companies. So you want that as well. And then third, and this is maybe more specific to me, I'm looking for something that, honestly will change an industry. I'm not looking to just invest in the second or third player in something, nor am I looking for, I like to talk about the difference between innovation and invention. And a new innovation is the latest dance craze, okay? That's an innovation. An invention is something that takes time and energy and research, and it's something that can change the world, not just be a fad, for a day or two. So I'm looking for things that are really quite different. And if I can, before I let you ask the question, the difference between venture capital and private equity. Well, sometimes they use private equity as the umbrella, of which venture capital is a piece. But generally, private equity means something else. So venture capital will write checks of generally $5 million, $10 million, maybe as high as $40 or $50 million into a new venture. And if you're a venture capitalist, your expectation is that you'll invest in 10 things. 5 of them will go out of business, and you will lose all your money. 3 of the 10 will they're known as zombie companies. They don't die, but they don't become successful. And they just kind of live on and suck on your blood for a long time. but 2 of them are going to be 10xers or more, and you're going to make back not just your entire investment in all 10, but more than that, and that's how venture capital works. Private equity is much more conservative. They'll write checks of 100 million, a billion, several billion in companies that already exist, right, are already somewhat successful, but not as successful as the private equity guys think they can be. And so the private equity comes in with a plan. It's either a turnaround plan, you're either buying companies that have had trouble, or it's a plan to combine it with other companies in order to create a healthier environment, or you just think that they are not well managed and you can manage them better. So Skype, for example, we bought Skype out of, when I was with Silver Lake, we bought Skype out of eBay, and we thought it was just terribly managed and wasn't growing as fast as it might. I'll be direct, we fired half the team, the entire management team, replaced, and I can tell you why. I mean, they didn't really understand what they were doing, and replaced it. It was 50% larger after we had turned it around, and we sold it to Microsoft several years later, and now it's a very healthy part of Microsoft. And so that's what private equity does. It's, but why did I go back into business? And then I'll let you answer. The reason is that private equity is largely turnarounds, and you work hard when companies are successful, and you work hard when they're not being successful, and you work hard when they're zombie companies. It's just a lot more fun when you're growing a company. And I got tired of turning companies around. It's not pleasant work and preferred growth. So sorry, go.
Oh, no worries. My name is Cody Yana. I'm a mechanical engineering major here. I'll have my master's and bachelor's both from here at the end of next year. Uh-huh. And I'm curious more about your thoughts on the MBA, because you went through, got master's in engineering, and then after that went back, got the MBA. But you've mentioned also that we already get a lot of exposure to that here. Yeah. So I'm just curious what your thoughts on the pros and cons are for it, both as like a CEO, but also if you were, as a parent, speaking to one of your children and they were asking this question. Right.
No, I'll give you exactly that answer, which is that I think it's very personal in the sense of, how, as I said, I was a real engineer and did not have any real sense of business. I was raised in a medical family, so, that's stereotypical, right? Medical families know nothing about business. So I felt I really needed, and I did, I really needed that education, and it helped me a lot in later life. I look at a lot of our engineers at Pure, and also when I was at Cisco, especially in the later years, and saw that you could get as close to the business as you had ambition to as an engineer. And those companies could teach you a lot about what it was like to, what you needed to know to be more successful in a business orientation. I think MBAs are good for a couple of things. One is for that reason, if you just really are much more intrigued with the business side of things and would rather shortcut, if you will, the longer learning that takes place in a company. It's also good, frankly, if you want to change in career. So the reason why a lot of people do it is that, and I'll tell you a truth about being in any business. You are pigeonholed no matter what you do by what you did in the last two years. Whatever you did in the last 2 years, your employer and other employers say, well, that's what you are. That's the only thing we can give you. So I'll give you a great example of this. So I had started, when I was by the time I had gotten to Cisco, I had started 3 companies. Cisco bought one of the companies that I didn't start per se, but I was employee number 12 or something like that. This was the Ethernet switch company. I was general manager of that, and they asked me to take over business development. So business development is M&A and strategic planning and all of that. And for reasons that I won't go into right now, I decided to do that. So for 2 years I did that, and I went back to John Chambers, the CEO, and I said, okay, I'm done with that now. I'd like to get back into operations. And he said, well, what do you mean operations? You're a BD guy, a business development guy. I said, I'm not a business development guy. Anyway, it took almost 6 months and my threatening to leave before I finally got back into an operating role. So no matter what you do, and then before taking this job, well, I was then a private equity guy. I wasn't an operator anymore. So whatever you do, you're stuck in the last 2 years. And a lot of people will get an MBA because they feel like they're stuck in whatever role they're in and they want to change. And taking that break as an MBA, it's a fresh start. You're reborn. You have no pedigree other than your MBA. And that's the way new employers look at you. So that might be the other reason to do it. All right, you choose. One in front. I'll repeat the question. Go ahead.
Yeah. Okay. So you talked about being arrogant
Right.
before starting
Right.
startup
Yeah.
after you finish school, and then it failed because of the crisis.
Yeah.
But would you do it again if you had the chance to do it again, or would you go straight to the MBA?
Yeah. Well, no, I did the MBA first, and then I came out and did it. But even then, I obviously didn't know enough. I made a lot of mistakes. I think
Would you
maybe
repeat
another
the
way
question?
Yeah, I'm sorry. She said, would I do it the same way? She said that, I self-describe myself as arrogant after getting my MBA and starting a company right away. But if I had to do it all over again, would I do it again? I will tell you that it was a very difficult number of years, during that period of time. And, but would I do it again? I probably would. But knowing what I know now, it's cheating because I would do it differently, right? Look, I think that as long as you decide that whatever experience you have, you're going to use it to learn. Because learning from, well, first of all, my best advice is learn from other people's mistakes. It's a lot cheaper than learning from your own mistakes. But then learn from your own mistakes, because we all make tons of mistakes, and make sure you're saying, well, why did I do that, and how could I have thought about it differently, and what was the lesson I should have learned from that set of errors or that situation, and then roll that into your next set of decision making. But learning from your own mistakes, or especially from other people's mistakes, I think is really really important. And as long as you do that, you'll roll from one thing to another. You'll learn from your mistakes, and as long as you're then brave enough to change what you're doing based on that, you'll be fine. So don't be afraid to make mistakes. Just be afraid that you don't learn from them.
All right, from the back part of the room, right here. So we'll take about 3 more questions. We have a good 5 minutes.
Hi, I'm Hudson. I'm studying business right now in undergrad, and I'm just kind of curious. You mentioned how you and your team are struggling to get that Wi-Fi project off the ground and running. So from an entrepreneurial point of view, why were you so confident in that project, and why did you continue to push forward with it?
Well, I had a laptop. I liked being able to be free in my home too. So probably not unusual. Before the Wi-Fi, I would have to go connect. I did have internet at home, but I'd have to plug in. And either I'd plug it in my office, in which case I'd be away from my family for the evening, or I'd have like cables, halfway through the house to connect into the den where the rest of my family was. And I just thought, this is stupid, and we're going to want to connect laptops with something. And the best thing that was out there was Wi-Fi. Now, or from my opinion, was Wi-Fi. Now, there were several other reasons as well. Now, remember, I had been watching it since the early 90s, but there were no laptops. And so when laptops came, that's when I decided it was the right time. But there was more to it than that. Ethernet was this sort of magical thing where it just kept on going up in speed, and even though there were lots of other options at the time, it was always Ethernet that won. And Wi-Fi finally got up to Ethernet speed. The first one was 11 megabits, which is the speed necessary to get real work done. And so I thought, this is all coming together, and therefore it should be successful. I was just confident it was going to be successful. What I didn't anticipate, and I think sometimes it's rather difficult to anticipate, is all of the ancillary stuff. Like the science was 10% of it. But then you had to have the management system, and you had to make sure that it was fire rated, so it could go up in the ceiling. And you had to have the security system right, and Microsoft had to support it, and it wasn't until we got all these things where it finally took off. And I suppose that our confidence was because we knew, once we started, we knew, okay, we need this, and we need this, and we need this. And we felt confident that once we had all those things, that it would be more successful.
2 more questions.
Can you just define some of the terms you've used, like operations and business development, and maybe contrast them and compare them with the position you're in now as a CEO?
Sure. Well, once you're in any senior management position, whether you're a general manager or a business development person or a sales leader, you're interacting with the CEO and the rest of the management team very actively. And so and by the way, if you're an engineer or an engineering manager, you're working with your general manager very actively. And this is where you start to learn about other parts of the organization and how they work and what their care-abouts are. What's really interesting in a company is that you're dealing with so many different constituencies that have so many different interests. Like the interests of a sales team and how they're motivated and how they work and the things that they need in order to be successful is so different than the things that an engineering organization needs to be successful. And they're motivated by different things. At the end of the day, they tend to be different kinds of people that gravitate towards these different communities. And so at one level, you start to become part of a group where you really want to understand what their needs and activities are so that you can support them better and service them better. And really being a CEO is probably where you get to the point where you've learned that, where you understand what their needs are and you're trying to best satisfy each of their needs. One of the things I tell my employees all the time is that I work for them. It's not really the case where they work for me. I work for them. I am there to make their jobs easier, to reduce bureaucracy, to reduce things that get in the way of them getting their work done. Who was it? I think, again, yeah, it was Peter Drucker again. Sorry, I like to quote Peter Drucker and others. But Peter Drucker said, most of what we call, and he wrote this a long time ago, most of what we call management is largely getting in the way of allowing people to do their jobs. In other words, it's a lot of blockages to letting people get their jobs done. And my job is to make sure that I'm running an efficient and effective organization, allowing people to spend 90% or more of their time focused on the customer and the product. Rather than internal bureaucracy. And you might think that that's easy, but it's not. Bureaucracy happens. And just by growth, bureaucracy happens. And by growth, by the way, companies have to change the way they behave or they get stuck. They become siloed. They become stagnant. And so you actually have to actively change the way companies operate in order to stay lightweight, in order to stay agile as you grow. And seeing the way that companies and groups operate give you better insight on how to do that. I hope that answers the question at least partially.
Does anybody have the mic?
It didn't answer the question? Oh, business development operations, okay. So business development is largely considered a staff position. And what you do is strategic planning, partnerships, mergers and acquisitions. So if you identify a company to go buy, actually execute that M&A transaction. But when you talk about being in an operating role or operations, you're largely talking about delivering products to customers. So you're either on the product development side, or the product management side, or you're on the sales side. That's more of an operating role.
So I will take one more question, but this is our kickoff class. So I wanted to let you know that after that question, I'll put up our attendance link, but I believe that Charlie will stay here for about 15, 20 minutes.
Yeah.
And you all are welcome in a very nice way to orderly come up and ask him questions. So we'll take one more class question before we close out.
All right. My name is Pranav, and I'm a junior majoring in CS. I just want to ask a question from a VC standpoint.
Can you put the microphone closer?
Yeah, sorry about that. Okay, so from a VC standpoint,
From a VC standpoint?
Yes, sir. Yeah. When you're analyzing a company's potential, do you think it's more important for them to have a strong engineering brand or managerial structure?
So not just from my own perspective, but I'll also answer, for example, I'm familiar with a number of the senior, some of the senior VCs. They are looking for a really strong technical team, there's no doubt. But they also want a strong managerial team as well. Now, they may decide to go with a really strong technical, if a managerial team has a weak technical team, then a VC is going to say, well, it's not a good managerial team. Because a good management team is going to have a good technical team. That's part of what makes them a good management team. If they see a really good technical team and they believe in the idea and they believe they're the best team to go do it, the VCs will still invest and they'll fire the management team and get the management team that they want. So that's what they'll do.
I hate to end on the firing note.
Yeah.
However, we know that you've had a 2-hour trip to come up here.
No, it's okay.
It has been phenomenal to actually hear you speak about so many different topics. I know students will have a lot of questions. Thank you for being a real kick-off speaker.
Thank you. Thank you.